Good morning, everyone. Yesterday, we were discussing about Ether channel. So we have discussed the configuration of Ether channel using layer 2 and as well as layer 3. So on layer 3, what we used to do, we used to assign the IP addresses, right? On the combined port channels.
Sir, I think you are mute.
Yeah. So in the port security, what happens that in this, what it does that it is going to control the traffic based on the number of MAC address. Now I'm audible, right? Am I audible? Am I audible?
Yes, sir. Yes, sir.
So in this, what happens that it is going to filter based on the number of MAC address. So if it is getting more than one MAC address, what it does? Shut down. And this is the default violation mode. It is. This is default violation mode. Then we have one more method. In this, what is a demerit that it is going to filter based on the number of MAC address. What if it is getting only one MAC address, but not the same, but with different one? So in the next case, what we can do, we will be specifying the MAC address. That's that this MAC address you have to allow. If you're getting any other MAC address, deny that, right? But in this, what happens that always you need to write the MAC address information. That's why we have one more method that we call as a sticky method. So with the sticky command, we specify that whenever you're getting like you're receiving any information on a particular port, then for the first time, what you have to do, you will learn the MAC address, and then you will make it as a sticky. And if you're getting any other MAC address, you have to deny that. And here we have discussed that this is the violation mode, and this is a default violation mode, but we will be having some more violation mode that is default one is shut down. Then we have is a restrict and protect. So in the both restrict and protect, your port is going to be up only. But what it is going to do, it is just going to deny the traffic. And in this, in the restrict, it will have violation count. Correct? No? So all these things we have discussed today. And yesterday also we have done the configuration of the port security. Fine. So today we will be starting with DHCP, Dynamic Host Configuration Protocol. Now this DHCP is which layer protocol? Layer 7 protocol. It means it is application layer protocol. Now, what happens? Why do we need this DHCP? See, what happens that in a network, you may have multiple end devices, correct? And to assign the IP on each of the end devices statically is going to be, it requires manual task. So go to individual devices and assign the IP addresses. Time consuming. That's why what we prefer this DHCP, where what it does, that we will be having a router or a server. We can have a router or a server. If you are going to have a router, what you will be creating here, you will create a pool where we will be having a IP address, pool of IP addresses. And based on that, it is going to assign the IP addresses automatically to the end devices. Automatically. So where we will be creating this pool? On the router, or we may also have a server. Based on that server or based on the router, end devices will receive the IP addresses automatically, right? Apart from that, this part, whenever you are going to assign based on this particular pool, this is going to have a lease time. What do you mean by this term lease time? Means whatever the IP the devices is getting, that is not going to be permanent in nature. It is temporary in nature. Why? Because this DHCP is preferred for the mobile devices. When I say mobile devices, it means that the devices that keep on changing its location. Fine. Now, for example, you are using your laptop. Now, when you are at your home, you connect to your home Wi-Fi, then you receive a DHCP IP. Then again, you went to some other place. You will connect to that Wi-Fi. Again, you will receive a DHCP, right? So your device keep on changing the location, and even it keeps on changing the network information. And based on that, what happens? It keeps on changing the IP addresses also. Correct, no? And once this IP address, let's say you have moved from one location to another location. Now you were here and you were getting the IP as 192.168.1.1. When you disconnected from this, then this IP is free now. It is free. It can be used with other devices also. That's why it is going to have a lease time. The reason, so that whatever the devices that is going to get the IP address, it should not get it permanently. Otherwise, if it has been assigned to you, now you change the location, then what will happen? This IP will not be free, and even your device is not connected. That's why we are going to have a lease time in the case of DHCP, and it is preferred for the mobile devices. Correct, no? So DHCP is a protocol used to dynamically assign the IP addresses and other network configuration parameters. It means here it says that it is not that only you will be getting the IP addresses only. No, what you will be getting? You will get the IP address, then you will get the subnet mask as well, then default gateway, and even the DNS server information. Okay, to device on a network. So what it is doing here, it automates the process of IP addresses allocation, reducing the manual configurations efforts and minimizing the IP address conflicts. How it is going to minimize the IP address conflicts? See, if you are going to have multiple end devices, then there could be a chance by mistake you have configured the same IP on the multiple devices. That will create what? IP address conflicts. But in the case of DHCP, this will not happen. This will automatically detect that the duplicate IP address has been detected. That's why based on that, what will happen? You will be or devices will be having the unique IP addresses. Even it is going to reduce what? Manual configurations. So DHCP operates on a model, and this model is called as a client and server model. In this model, who is the client? Client is the end host. Host or end devices will be called as a client. And who is the server? Either we can take as a server or we can take as a router, where we will be creating a DHCP pool and from where the devices on end host is going to receive the IP addresses automatically will be called as a server. So we will be having a client server model. It means a relationship between the client and the server, right? So in this, who is the server? It says that who is going to manage a pool of available IP addresses and leases them to a DHCP client upon a request. It means what? It means here that it requires a request. Without request, how it is going to assign the IP addresses? It means who will request that? End devices, end host. It means you can remember in this case that whenever in the DHCP server client model, if the devices has to communicate, who will initiate the communication? Client, host. Then only server will respond. Okay. So DHCP client is what? These are the devices, computers, smartphones, etc. that request and receives the IP configurations from a DHCP server. Got the point till here? So DHCP is an application layer protocol that is used to assign IP address, subnet mask, default gateway, and DNS server information to the client or host. In short, we can say that is end devices. It reduces the manual effort to assign IP addresses to the multiple end devices. And this reduces IP address conflict. That's why it reduces even the IP addresses conflict. DHCP operates on client server model where client will request to the server to assign the IP address automatically. Fine. Now, as it is going to operate on a client server model, it means there will be certain messages exchanged between the client and server. So that particular messages will be called as what? DORA messages, or we can say DORA process. So we can write here, it operates, not operates, we can say that, or it sends the client and server model is based on DORA process, where D is equal to discover, O is equal to offer, what is R, request, and A stand for acknowledgement. So who sends this discover message? Client. Discover message is sent from the client to discover the server who can allocate IP address automatically. See, I'm not writing all these things, submit mask default gateway. It is like you can understood here that all it will also include other things, submit mask, default gateway, and DNS server information. So DHCP discover message is sent from the client to discover the server who can allocate the IP addresses automatically. And this message will be in broadcast form. Why? Because it is asking everyone that who is there any server who can allocate me the IP address? Now, if it has to ask to everyone, it means it has to send in a broadcast form. That's why it is here the broadcast message. When this message reaches to the server, then server has to give an offer. What it will give? Offer message. So offer message is from the server side. And in the offer message, it contains the information regarding the IP address and its subnet mask, default gateway, and DNS server that it is willing to allocate to the end devices. Fine. And this offer message will be in either broadcast or in unicast form. When you are using a Cisco devices, understand it clearly here. When you are using Cisco devices, in that case, offer message will be always in the broadcast form. But when you are using any other devices, in that case, offer message can be unicast form. Okay, so it depends upon the devices or operating system that you are going to use. So it says here that offer message is from the server side, and in the offer message it contains the information regarding the IP address that it is willing to allocate to the end devices. And this message can be in broadcast form or unicast form. Why it sends in a broadcast form? So that it updates all other devices in that network that see I am willing to allocate this particular IP to this particular devices. To inform all these other devices the same thing, it is going to send it to the broadcast message. And in what case it can send it as a unicast? When any particular devices, let's say for example, there was a device, it has connected to a Wi-Fi. It received a IP, then it got disconnected. Later on, it again connected. Then you will observe there that it is going to receive the same IP. And how it is going to receive that? Based on the unicast form. So what happens that when it is getting connected again, and when it sends this request messages, in that case, that DHCP come to know that already this device has got connected, and the same IP is it, and it tries to get the same IP. In that case only, it is going to send in the form of unicasting, right? And then once this offer message reaches to the client, then what the client does? It sends a request message that I am okay with the message. Request message will be confirmation from the client confirming the use of the mentioned IP address in the offer message. This message will be in broadcast form, right? And once this message reaches to the server, then it has to send a final acknowledgement message from the server confirming the allocation of IP address, confirming the allocation of the IP address to the particular device. And same thing that this message will be in broadcast or unicast form, right? So in the client and server model, these messages will be exchanged between the server and the client. Now DHCP operates on a port number. DHCP server side uses the port number as 67, and DHCP client side port number is 68. DHCP uses UDP. It uses UDP for communication purpose, not TCP. Right? So see, you can see here that if there is any connectivity to any Wi-Fi, what will happen? The devices will be receiving the IP addresses from where? DHCP. Now, what is the advantage of this particular DHCP? Here it says that it simplifies network administration by centralizing the IP address management. It means we will be having a centralized control system who is willing to allocate the IP addresses to all the end devices. That's why here what we have centralized management system. It supports automatic IP configuration for mobile and temporary devices. And it reduces what human errors and ensures efficient IP address allocation. So here we have is discover sent by the DHCP client to find a billing DHCP server. To locate the DHCP servers, client sends a DHCP discover message. Offer is sent by the DHCP server to offer a lease to that client with a specific IP address and inform the client of the other parameters, including other parameters. Then we have a request sent by the DHCP client to ask the server to lease the IPv4 address listed in the offer message. The parameters listed in the offer message, it is going to ask to allocate it. And finally, we will be having what? Acknowledgement, who will be sending this sent by the DHCP servers to assign the addresses and to list the mask and default router and DNS server IP addresses. And this is like a what? A confirmation message. Right? Now we'll take the devices and we'll see how it is going to allocate the IP. Because when it is requesting it, so it is confirming all other devices that I am going to receive this IP addresses. And this IP belongs to me. On this, we'll have IP 10.1.1.1/24. So this IP belongs to one network that is 10.1.1.0. Now come to this router. What is the host name we'll give? DHCP server. Now on the interface, G0/0 IP address 10.1.1.1.255.255.255.0 and give here no shift. Need to fix it. Then we need to create a DHCP pool here. How will you create that? IP DHCP pool. Now it will ask you to give a pool name. IP DHCP pool name. Let's say IP DHCP pool 01. For network 01, I am creating this. That's why I have mentioned this. IP DHCP pool subnet 01. This is the first command. Then this pool you are going to create for which network? You have to specify the network for that. For which network I am doing this? 10.1.1.0. Then subnet mask also we have to write what is that /24 255.255.255.0. Means I'm creating a pool for this network. So whatever the IP is coming under this network will be used to assign the IP to the end devices. Right? Then you need to specify here default router information also. We always say as a default gateway, but in the command, in this command, we have to write as a default router. And here we need to write the IP address of the default gateway of the router. What is that? 10.1.1.1. And in this subnet mask is not required. Then you will have to write here DNS server information. Let's say we can give it here 8.8.8.8. This is a DNS server IP of the Google DNS server. Then you will be specifying here any range. Let's say if you are just giving this much command, then it is fine. It will work. Now, if you want to exclude certain addresses that I don't want my end device should receive any of this IP. So for that, what will you give? IP DHCP excluded address. I will be giving a range from that I don't want my devices should receive the IP. Let's say I don't want it from 10.1.5 between 10.1.1.10. This is the excluded address that I have given here. Fine. Done. Now give exit. Come to this PC. Desktop. IP configuration. Is it static? No. Sorry. First it is static. Now we have clicked on DHCP, so it will receive. Received. Now we have denied it from where? From 5. That's why it is able to assign 2. Right? Now see. Desktop. IP configuration. DHCP. What is that? 3. Desktop. IP configuration. What is this? Desktop IP configuration. Change to DHCP 11. Right? It is not assigning 5, 6, 7, 8, 9, 10 like that because we have denied that. Got the point? Clear, no? Now, even if you take here one more device, let's say one new device came and it wanted to connect. When it will connect here, what will happen? Come to simulation and check. Desktop IP configuration change to DHCP. As soon as we change to DHCP, what happens? It generates one message. What type of message it is? See, layer 7 packet server. This is telling you that server is unknown and client is also unknown. For that, see at layer 2 what it sends. That at layer 2, it is going to have the source MAC address. And what is the destination MAC address? As all F. That is going to be called as a broadcast. That's why it is in the broadcast form. When it will send to the switch, what the switch will do? Broadcast it. What is happening? Okay, in the background, multiple things running. That's why it is happening like this. I should have just clicked over the DHCP. For that, we need to filter everything. Everything is enabled, no? If you have to disable everything and then you have to keep only one thing, that is DHCP. Then only it will show you DHCP messages. Fine. But just we have seen that, okay, when it is sending it, so it is sending in the broadcast form, right? Mm. On real time. And now check the IP. You see, in which case it will get this message. DHCP failed. See, if let's say it is unable to receive any IP address from the server, or if the server is unable to allocate any IP address to the client, in that case, it is going to get the IP as a APIPA. What is APIPA? Automatic private IP address. Right? What is APIPA? If DHCP server fails to allocate the IP address to the client, then client will receive a PIPA that is automatic private IP address. Correct? Huh. Because it is reason because it is failing to assign. That's why it will receive a PIPA address. This is temporary. Huh. And it is going to be ranges from 169 dot. See here. 169.254. Okay. So this belongs to which class? A PIPA IP? Class B. Okay. This belongs to class B. Huh? Do we have classes in IPv6? Tell me. Telling that same problem. When you will come to that Fine. So here what it gets a pipa, but as soon as you will wait, if it is working, then it will allocate the IP also. So now it allocated where it is going to have this IP, subnet mask, default gateway, and the DNS server information. Clear till here? So in this situation, what happened now that my server was in the same network. Where is my some server? In the same network. There can be a situation where server will be in different network. For example, let's say we'll be taking one more router now and one switch. And then we have multiple PCs. Let's say we will be having here one, two, and three PC. Fine. We have one IP 192.168.1.1/24, for example. Okay, or you can change the IP as well. That 192.168.1 dot 1.65/26. Okay. So now what will happen that you have to get the IP addresses for all these PCs. Now, if you want to create a DHCP server on this router, and when you will receive the IP, then this is the exactly same concept. But I don't want it to happen. It means in this situation, what will happen? What I am considering that these are my end devices that is connected with one router. But in this case, I am not going to create a DHCP pool on this router. Rather than that, I will be creating a DHCP pool on this router, and this router will be responsible for assigning the IP addresses to the automatically to this all these three end devices. Now, what could be the situation? Why do we need this? Because always you're not going to create DHCP pool on all the routers. You may have a centralized router who is responsible for allocating that to all the different networks. Means instead of having DHCP pool on all the respective routers, we will be having a DHCP pool on one single router, and that router will be responsible for sending the IPs to the all the individual different network connected with other different routers. Fine. And this concept will be called as a DHCP relay agent. What it is called as a DHCP relay agent. For that, what you will be doing here, that first you need to have a connectivity between them, right? Then you will create a DHCP pool. You will create a DHCP pool for which network? This network. Once you have created the pool, then you have to configure a helper address command on this router. What will you configure? Helper address command. You will tell him that, see, I know that you cannot be able to assign the IP to my end devices. What you do? You take help from him to get the IP. In that case, it will give the IP and you assign it to the end devices. Right? Now, see, this is one network. This is one another network where I will be having 192.168, 1.64. You know how? Hmm. And here also I will be having one network. It means total two router, three different network. Routing is required. Yes. then you will be have to do routing. Then what will happen? This devices will receive the IP automatically. So we'll configure this now.
But sir, you have said that R1 as server won't be issue.
Huh?
You have said R1 as server.
We can like R1 is acting like a DHCP server.
Yes. It won't affect while routing.
No, no, it is router only. No,
Yeah.
that's right. So on this interface, let us give one IP as 172.16.1.1/24. And here we'll give as a 172.16.1.2/24. Then here we'll be having one network 172.16.1.0 network. Then come to the second router first and assign the IP. 1 minute, let's say that this is DHCP server. And this is DHCP client help address. It means here this is a location of what? DHCP server. And here I'm having host, or you can say client. And this router will be acting as what? Relay agent. And this is agent router. Now come to this router. CLI config space T. What is the host name we'll give? DHCP agent. Now on the interface G0/0, IP address is 192.168.1.65.255.255.192. Give no shut and give exit. And on this interface, G0/1, IP address is 172.16.1.2.255.255.255.0. No shut and give exit. Come to this router. Host name. Sorry, host name is not there or not required, already we have given. So G0/0 1 IP address is 172.16.1.1.255.255.255.0 and no shut, give exit. Done, configured everything. Now you have to create a DHCP pool on this router. Create that. What you will give? IP DHCP pool. Again, one name we have to give. So let's say we are giving it for subnet 02. Subnet 02. Then what have to give here? Network. Which network? Where I have to, for which network I'm creating this? This one, no? This network. So I have to give this network. What is that? 192.168.1 dot. This, that's why I've given you this times. So that break your momentum of 0. Always you consider network address as 0. That's why. Then What we have to write here? Subnet mask. What is that? 255, 255, 255.192. Then default router. You know that all for all these PCs, which one is the default one? This one, no? So 192, 168, 1.65. DNS server, let's say 8.8.8.8. And here I'm not going to exclude any address. It remains same. That's all. This is the command I will be giving where? On the server. Correct, no? Then you need to come to the client where you will be configuring what? Relay agent command. Now you tell me that this particular router, the agent router, is going to allocate the IP address through which interface? G0/0. So I will be taking the help on this interface only. So write down that interface G0/0. From where you are going to take the help? Server, IP, helper, address. What it says? IP address. We have to write. Which IP address? The server IP. Server has how many IP? Two IP. Any one IP you can write because both are for the server only. So let's say I'm writing here 10.1.1.1 IP helper address. Done. Where you will give this command on the agent router. Done. Then based on this also they will not get. Why? Routing is required. Correct, no? Who will tell me the routing command? I am on the first router. I have to reach the second network. Tell me the IP routing command. Yes. Yes. What is the destination network address?
1.64. 1.7.255.255.1.62. Stop.
What is the next hop?
1.8.132.15.1.0.
1.2. Done. You given the command. Come to this PC. Desktop. IP configurations change to DHCP. Okay, we may also have to give the routing command from this router, no? Because they will keep on sending client server model is there, no? So they both will exchange the message. So I have given routing from here to there. Even we should have a routing from this network to that network. IP route, which network? 10.1.1.0 with 255, 255, 255.0. And what is the next hop? 172.16.1.1. Correct, no? Got? What is the IP you are getting? 192, 168, 1.66. Correct, no? One dot 67. and 1.68. Correct? All the information is there. Subnet mask is also there. Default gateway is there and DNS server is there. All the things we are getting here. So write down the commands. First, we need to create a pool. So IP, DHCP, pool, and then give a pool name. Then for which network you're going to create this, so you will write here network, then that address and subnet mask. After that, default router. Then you will write the IP address of default gateway. Then DNS server. Now this command is optional. IP DHCP excluded address. See, always try to use tab button while writing the commands. If you have written IP, then write DH, use tab. All the full commands will come. Tab. Not that tab, tab. Done. And for the relay agent, what command we will be giving here? Interface, then interface number and IP helper address. And here you will write the IP, right? So this IP will be of DHCP server. And which interface? And this interface, which interface? Interface number through which the end device is connected. Means not directly end devices will be connected, but from switch, then end devices, like that. Clear, no? And for reference purpose, you can take this. I know IP is not visual, but IP you can assign from your side as well. Is it clear? DHCP and DHCP relay agent. Clear, no? Then in the DHCP only, we have one more concept that is called as a DHCP snooping. Now, what happens? Let's understand this snooping concept using the topology only. Here we have one router, then one switch we have taken, and with that we have multiple end devices. Then we have taken one server here, and based on this server only, we will be assigning the IP addresses automatically to the end devices. It means this is what? DHCP server. And the router will be acting as what? Same, again, agent. So IP address on this interface is going to be 10.0.0.1. Here we'll assign the IP as 20.0.0.1/8 you can consider, okay? And here we have 20.0.0.2/8. Now come to this router. Enable config space T. Again, we'll have to give a host name to this DHCP agent. Now on interface number G0/1, we have to give IP address is 10.0.0.1 255.255.255.0, and here give it no shut. Oh, no IP address. Okay, again give IP address 10.0.0.1 255.0.0.0 and give no shut. Fine. Interface G0/0 IP address is 20.0.0.1 and 255.0.0.0 and give it here no shut and give exit. Till here it is clear. Now we will come to the server. We need to assign the IP first on the server. Come to desktop IP configuration. What is IP? 20.0.0.2. This is a submit mask. And what is the default gateway? 20.0.0.1. This is a default gateway. Now, once you have done this, now we need to come to on the server only. Come to services. Come to DHCP. Are you seeing here service? First, you need to give a pool name. Let it keep same only. Default gateway we need to write. Now for all this PC, what is the default gateway? 10.0.0.1. Now, what is a DNS server? Not mandatory, but we can give 8.8.8. Now, what is the starting IP that I want my PCs to get? Is from 10.0.0.2. Already one is given to the default router. This is a subnet mask. This is the maximum number of users. Everything is done. Save and on this. Done. Just we have on it. Then what will happen? We need to come to this router, and here I need to configure what? Relay agent command. Where I need to configure this on which interface? Interface G0/1. IP helper address. From where I have to take the help? Server IP 20.0.0.2. Give exit. Now come to this PC. Desktop IP configurations change to DAC. Got? Got the IP 10.0.0.2. Same here also. Received. Check here also. Got the IP. Understood this? Now, this is the normal scenario where everything is working fine. My end device is able to receive the IPs also from the server. Later on, what happened? That there was one user who was not like he wanted to do some misconfigurations. What he did, he wanted to allocate IP address to the end devices from his own server so that these all PCs should not communicate with the real server. And with the help of that, what it will do? It will direct all the traffic towards its own server, compromising all the data and information. It means it is affecting what security feature of the system. And this type of thing is called as a DHCP spoofing. Spoofing. And what type of DHCP server will be called as a rogue DHCP server? What we are discussing now? We are discussing now DHCP spoofing. Okay. And here you will be taking one fake server. That server will be called as what? Rogue DHCP server. Fine. So what happens here? That we have taken one server. Then we will connect this server, or let's change the name. And you will connect them. And they will also receive the IP. But in this case, they will be receiving the IP from where? Means this particular server will receive the IP from where? From the original server only. Okay, come to the server. It is not going to allocate the IP to the system manually. It will obtain it from the server only. For that, come to desktop, IP configuration, change to DHCP. Received. What is the IP? 10.0.0.5. Now what it will do? Come to services. Come to DHCP. Again, it will create a DHCP with the same server pool name. This time, the default gateway will change. 10 dot 0 dot 0 dot. We can give any random also, but we have to give any other IP, not the IP of the router. Let's say I'm giving it for the server only, 10.0.0.5. But we can give any other IP, but it should be of same network. Then starting, change here also, 8.8.8. Starting IP address, I want it that my PC should get it from, let's say 20. At present is 2, no? Let us make it as a 50 only. Fine. Save this on it. Done. Come to this PC. I have changed the default gateway, right? IP configurations, change to static, change to DHCP. What is IP? 10.0.0.50. It means now it is not collecting the information from real server. From where it is collecting? It is collecting the IP from the fake server, right? Because we have changed the default gateway information. And also that particular device is, this is closer, right? In the same network. Then if you will come to the second device, same thing you will do static, change to DHCP. What it does? 52. Same come to this PC, static, DHCP, 51. And what is the default gateway? 10.0.0.5. In this case, what will happen that your PC will not be able to communicate to the real server. You give command ping to 20.0.0.2. What is going to happen here? It will not ping only. Request timeout. Correct? Not pinging. Then we need to avoid this. We don't want that any other device should get connected with my switch and should allocate me the IP addresses automatically. For that, we will be using one concept that is called as a DHCP snooping. What we need to use here? DHCP snooping. The process where it is using to assign the fake IP, or not fake IP from the fake server. That process is called as a spoofing. To solve this, snooping. Okay, this is a layer 2 security feature. So in this case, what we are going to do here, that you need to create a trust interface on the switch, where we need to configure this on our switches only. Now you tell me that which one is your trusted port here? F01, F05 is what? Untrust, no? So I'm not going to make command or give command for untrust port. I want to give command for trusted port. So automatically, if F01 is my trusted, then rest other is what? Untrust. So I will not be able to receive any traffic, means DHCP traffic from that particular untrusted port. So come to this one. On a switch, enable config space T, give interface F0/1, IP DHCP snooping. IP DHCP snooping VLAN, and by default, which VLAN it is? 1. IP DHCP snooping VLAN number 1. IP DHCP snooping interface number F0/1 IP DHCP Snooping trust. What I am telling? Trust. Which one is my trust? F01. If F01 is my trust interface, it means it is going to receive it from the trusted only, not from the any untrusted interface. Give exit. Done. Got from real device, from real server. Correct now? What is the default gateway? 10.0.0.1. In this situation, it is not that this server is not replying, it is replying. But this switch is denying the packet. It is not allowing to reach to the respective end devices. Correct now? Same here also we can check. Fine. And same, you can check it here as well. Got? So what is the command that we have tried? When a ROG DHCP server assigns the IP address and other parameter to the end devices in a network, then this is called as DHCP spoofing. To prevent the devices to get the IP from rogue DHCP server, we use DHCP snooping, where we create a trust port using DHCP snooping command on switch, and based on that, it deny the messages coming from untrust port.
Vishal.
Yes.
So when we use firewalls, there the still you like you have to configure this, or just you have to just
No, no. In that case, we don't need to configure, but we are considering here that how we can implement this security feature on a switch directly without having any other additional devices.
okay. But still, yeah, when you are using firewall, then it's no need of this
No,
snooping, right?
there we can, based on different policies, we can create or deny the traffic. Okay, so now what is the command that we have to give? IP DHCP snooping, IP DHCP snooping VLAN and VLAN ID IP DHCP
interface.
interface number and IP DHCP snooping trust. Then this week completes DSC. Next topic that we have to discuss is DNS. See, what is DNS? DNS is domain name system or domain name server. Now, why do we need this DNS? See, what happens that whenever we are trying to reach any website, so what we remember for the websites? Domain name, let's say facebook.com, instagram.com, google.com, cisco.com, everything. But do you know the IP addresses for them? No. But our devices has to locate them using what? IP addresses, because they understand the numbers, not the names. But we human beings are able to remember what? Names, not the numbers, right? That's why we prefer this. We have the concept called as a domain name server. So it says here that in the world of networking, computers don't go by names like humans do. They go by numbers. And that's how the computers and other similar devices talks and identify with each other over a network, which is using by a numbers. That number is called as what? IP addresses. And that's why this DNS is used to bridge the communication gap between the computers and human readable or human communication with the help of this DNS that is used to resolve the names to the numbers, or we can say numbers to the names like that. So DNS uses both TCP and UDP for communication purpose. And it uses port number 53. Whenever any question comes in the interview regarding the DNS, they will ask you the question why it uses TCP and UDP both. Tell me the scenario, right? One more question can be what are the different DNS servers? Then, if you are trying to reach any website, tell me what all the process it is going to follow to reach that particular server, particular domain server. So in this, it says that what happens that first we will be having a DNS query. When you enter a URL, what is that URL? Uniform Resource Locator. In your browser, your computer sends a query to a DNS resolver. What is that DNS resolver? It is usually provided by your ISPs or a public DNS services like a Google. So whatever the nearest DNS it is going to resolve that, it is going to ask that I wanted to reach here, this particular domain. But if that particular DNS query is not going, this particular DNS resolver is not having that information, see, it is asking to whom? DNS resolver. When it is asking to the DNS resolver, what it is called as? DNS query. And if it is not having this information, then this message will be asked further. And this will be called as what? Recursive query. So it says that the DNS resolvers start querying other DNS servers to find the correct IP address. So one server will be not is not having that information, then it further move to the next server. And this is called as what? Recursive server. Sorry, recursive query. One is normal query, then one is what? Recursive query. Then it finds what? Root DNS server. Now, what is that root DNS server? The resolver first contacts to a root DNS server, right? Now it says that which responds with the address of what? Top level domain. Example is what? Dot. So what is that top level domain? See, root DNS server is dot. TLD server is .com, .in, .org, .uk, like that. These are the top level domain. So root DNS server, that is dot. Then it is going to further ask to whom? Top level DNS server. Then server the resolver then contacts the top level domain servers, which provides the address of an authoritative DNS server for a specific domain, example .com, .in, and further I have written here. Or we can say .net also. What is .com? Commercial. What is .in? India. Okay. What is .org? Organization. So when you will try to visit the page of WHO, World Health Organization, what you will be using? .org. When you visit government websites in India, gov.in, right? So it says here that we will be having authoritative DNS server. So what is this authoritative DNS server? This is the final server who is having the IP of domain. Okay. So the resolver queries the authoritative DNS server, which knows the exact IP address of the domain. Correct? No? So you can see here that what are the process it is going to follow. This is my root DNS, and this is what my PC is, right? So in this, a query will be generated that is going to reach. Then further, it is going to ask to whom? Root DNS server. This process will be as called what? Recursive query. Then it will reply. Then further, it will ask to the domain, top level domain. Then further to whom? Authoritative DNS server. And based on that, it is going to get the information finally. And then it is going to reach here. So it means that there will be multiple different servers existing. Can we merge them? No, we cannot merge them. It is ideal to put it separately only. Now it happens like I am telling you that it goes to root.com, TLD, authoritative, then it finds the IP. But when you type any website name just with a frequency or like very minute seconds, you are able to reach there, right? How much time it takes? How much? Around 20 milliseconds. In that time, it is going to find that. And based on that, we are able to reach. Fine. So in this that it is showing you how this is a client server, then it will tell the server this is the IP. Then based on that, it is going to find the IP. Right. Same thing it is there. IP header, UDP header information will be there. What is in request, what it does, what is the IP address of the Cisco.com, because it is trying to get the IP of what? Cisco.com. Better it is explaining you in this slide only how to get. Then in this, what happens now, when it get the record, it communicates, it gets certain types of messages. So what it says here that if you're getting a record type, then it is called as a record. What is a record? A record is called as a address record. What is a record? Address. Maps a domain to an IPv4 address. What it does, when it do when it is going to identify the IPv4 address of a domain, then it is a type A record. Okay. Then what we have? 4A record. In the 4A record, what it contains? IPv6 address record. It means it maps a domain to an IPv6 address. These are very important things I'm discussing. And these are very important for the interviews. Then one more what we have, CNAME. What is the name? Canonical name. Map one domain to another domain. Instead of asking or knowing, finding the addresses, what it does, it finds the other domain name. This is called as a CNAME. MX is what? Mail exchange. It specifies the mail server for that particular domain. Right? Identifying the mail server for that particular domain that we have asked. This type of messages you will be getting in the MX record, there where it is going to have mail exchange, and this is for the mail server. Even if you remember that the terms and it use cases, then it is fine. That A record is for what? IPv4. Triple A is for 4A is for the IPv6. CNAME is for the asking from one domain to another domain. MX is for the mail servers. What is NS? Name server. It specifies the authoritative DNS servers for that domain. It means that if you are trying to reach this particular domain, then this is the authoritative server who will be giving you the information regarding that. And where you will find that information? In the NS, that is name server record. Fine. Then what we have? SOA. What is this? Start of authority. Contains the admin information about the domain and DNS zones. Now what happens now? We will be having different zones in DNS. Just in the next slide, I will discuss about the zones. What is the use of the zones in the case of DNS? So you can understand that here it is going to contain what information regarding what? The domain and the DNS zones. Where? In SOA. About that serial and the TTL time to leave. Then pointer record used for reverse DNS. Pointer record is for what? Reverse one, where you will be mentioning the IP and it will find the domain name for that. Reverse DNS. Pointer record. And this is one text TXT for text echo record that carries text data, often used for SPF, DKIM, DMARC, domain verification. This is for security purpose. You will be discussing about this in detail in the email exchange. Right? But I have given you one slide for that as well. Just you need to have a basic understanding about that. Even if you're not able to remember, no problem. In this, it contains SPF. What is SPF? Sender Policy Framework. It is used to verify that an email is sent from an authorized mail server for that domain. What it says? To verify that an email is sent from an authorized mail server for that domain. Means that email that is coming, it is from the authorized server, or authorized domain server only. So this record lists of all the IP addresses or the mail servers allowed to send emails on behalf of that particular domain. This record lists of all the IP addresses, all the mail servers allowed to send the emails on a behalf of that particular domain. Examples like google.com. Fine. If you're interested, you can search about these things. Search about the examples for this. DKIM, domain key identified mail. This is used to ensure that email content was not tampered with and actually comes with from the claimed domain. Means Based on that, it is giving you that this is coming from a legitimate domain, where it is going to have what the sending mail servers signs the email with a digital signature, and it is containing what private key encrypted. The receiving server verifies the signature using what public key stored in your domain DNS text record. When I will start VPN, there I will explain you all the types of encryptions, public key, private key, everything. Okay. So DKIM is for verification purpose. And same, this is also for the same function only, to verify that it is coming from an authorized server. And DMARC is for what? It uses both, combination of both. Or you can, in a simple term, you can understand that DMARC is going to check whether SPF and DKIM is working or not. So domain-based message authentication, reporting, and conformance. So it combines SPF and DKIM and tells the recipient mail servers what to do if either of them fails. So if either of them fails, what it does? Deny. Okay. So DMARC checks whether the email passes through SPF or DKIM, whether the domain in those checks matches from that particular domain or not. Whatever that has been specified, is it correct or not? Okay. Don't worry. If you're able to understand this part and this part and this part, it is fine. I told you we have a zone also. So what is the meaning of zone? It says here, a zone in DNS is like a portion of the database that stores information about a specific part of domain. What is zone? A zone is a database. Which database? Database of DNS, where it is containing the information regarding the domain. Regarding what? So we can have multiple domain also? Yes. Yes, we can have. In a zone, we can have multiple domain and its database. Right? So this is called as a zone. Now, in general, DNS uses UDP. But when it is going to communicate outside in zones, mean whenever we have zone transfer, then it uses TCP. So in general, whenever you are trying to reach a website, in that case, it will be using a web UDP to resolve the IP for that particular domain. But whenever we have any zone transfer, outside your zone communication is there. In that case, it will be using here TCP. One condition. Remember that. One more condition. If whenever your DNS is trying to resolve and size of the data is more than 512 bytes, then it uses TCP. Got the point? When it uses TCP, DNS uses TCP when zone transfer is there and when it has to communicate outside its zone, or when the size of data is more than 512 bytes, then it is going to use what? TCP instead of using what? UDP. So it says here that what is a zone? See, a zone, DNS zone is a portion of DNS namespace that is managed by a specific organization or administrator. A DNS zone in DNS is like a portion of DNS database that stores information about a specific part of a domain. A specific part of a domain. Then it contains a zone file is a plain text file stored where in the DNS server that contains an actual representations of the zone and contains all the records for every domain within the zone. So this is what a file will be there about that particular domain and contain the information regarding the within that zone. So that particular information will be stored where? There can be a primary zone, secondary zone, or stub zone, forward zone, and reverse zone. So what is a primary master? It contains the original copy of the zone file. Primary master is what? It contains what? The original copy of the zone files, and it can be edited. Whereas we have one secondary that is going to contains a read-only copy of the zone file. It means you cannot edit this. What you will be doing here? Just you have to read of the zone replicated from the primary server. It means copied from the primary server only. Then what we have a stub zone contains only NS records pointing to the authoritative servers for a delegated zone. Who is going to contain the NS record? Stub zone. What is NS record? Name of authoritative DNS server. Okay. Forward zone. Forward zone is formed when you are finding domain names, when you're resolving domain names to IP address. This is called as a forward zone. What is reverse zone? When IP address to the domain name, reverse direction. Is it clear? What is the port number of DNS? Port number is 53. Clear? In this, what is the most important thing you have to remember? The DNS server, the flow of the packets, how it flows, how it queries everything. All the steps, if you remember, then it is fine. And when it uses TCP and UDP and zones, and these are the types about that, and some of the records. Clear? So we have done today DNS, DHCP, DHCP relay agent, DHCP snooping. Tomorrow we'll be starting with the syslog and SNMP. Fine. We'll stop the recording.